Okay, I think we're all set now. So inductive reasoning, the notes are super short. Okay, so first I just want to remind you about deductive reasoning. This is the one that we really like, deductive reasoning. And this is what we try to do in our 2-column proofs is deductive reasoning. This is when you are trying to prove something true in all cases. We use definitions, theorems, to make conclusions. So deductive reasoning is when you take a pile of facts and you follow those facts to make a deduction based on facts. Inductive reasoning now, we're going to be doing things more like looking for patterns, seeing if we can sort of use some past experiences to predict what is happening coming up. So that is inductive reasoning. Using past patterns to predict future results. So whenever possible, we try to do deductive reasoning because we want to make conclusions drawn on fact. Inductive reasoning, though, I mean, it's useful, but it helps us sort of get an idea, and then maybe I'll try and prove that idea using my deductive reasoning. Okay, so for example, I can't remember if it was this class or not. If I could you imagine a scenario where it's a beautiful sunny day, you decide for whatever reason you're going to go to the movies, you go in, you watch a movie, you come back out, and now you walk outside and everything is all wet. What do you surmise has happened? Yes. Right, you assume that like, oh, I came outside, everything's wet. Based on your past experiences, you have a pattern that you've experienced before. You come outside, everything's wet. That's the natural conclusion. Oh, it must have just rained. Weird, right? Do you know for a fact that that happened? No. I mean, like maybe it was the fire department's training day with their new
fire truck that came by.
It's possible, right? But so you can see, it gives me I can use my past practices and usually it's fine, but it could happen that I'm wrong there. So it can be faulty to do inductive reasoning, which is why we try and rely on deductive as much as we possibly can. So let's try, we're going to look for a pattern and some numbers. And then I'm going to have you do a little practice worksheet on inductive versus deductive. And that's pretty much it for 3-6. Okay, so let's say find the next two terms. Let's say I gave you 2, 5, 14, 41, 122. Find me what two numbers you think would come next. I'm going to give you a second example also. Let's do, okay. I could be one that always throws people off too. All right, try those three. See what you can come up with. Anybody think they have an answer for number one? Carson, go ahead.
The next two terms would be 365 and 1,094.
Hi. Thanks. I agree with you. What was the pattern that you found? Go ahead, Carson.
Multiply by 3, subtract by 1.
Oh. I don't think that's what I did, but let me see. 3, subtract 1. 14 times 3. Ah, that totally works. Did everybody do something different? Aiden, what'd you do?
Like 3 times like 3 and you add that to the number. You're adding times 3.
Yeah, that's what I did. But how interesting that we have two really different patterns, but it's producing the same results. So I had said, okay, to get from 2 to 5, I add 3, and then I noticed, oh, from 5 to 14, I'm adding 9. Then you're adding 27. So you start to see this pattern emerging. I'm adding 3 times. So if I multiply those together, I'm adding 27. So then and it just keeps going up by times thinking by 3, I believe. So that's 81. If I did 27 times 3, I add 81. Now I'll do 81 times 3. What's that? 81 times 3, 243. And then I'm just adding. But I like Carson's way too. Times by 3 minus 1. Oh, interesting. Okay. Anybody get answers for the second one? Well, one thing we notice is that our numbers are going down. Yeah, this one, if you find the difference between them, it's a consistent 2.3. So I'm decreasing by 2.3 every time. So I just continue right along doing that. So I think the next two end up being, I have it as 1.2 and then negative 1.1. Did I get to the third one? Carson,
And I think I have
what do you think goes there?
17 and 19.
I agree with you.
Was the pattern that it was multiplying numbers?
Yes. So the primes, did you see it? Now listen though. It literally, I mean, you don't, this could have been a list of my favorite numbers. How would you have known the next two, right? But if you can find a pattern, we can, that's what I'm, with inductive reasoning, it has its limitations. It can give me a good starting point. Do I know for a fact that that's the pattern? Maybe, maybe not. If I had the more entries I have in the list where I can figure out the pattern, the more confident I am that that's the pattern, right? What if I only gave you like 2, 3, 5? You could have come up with so many different things that would come after that. There's tons of things. So the more you have, the better you can kind of sort of piece things together and try and find a pattern that holds true throughout. Okay, so there's inductive versus deductive. Let me go ahead. I have a little half sheet for you to practice, just some differences on the two. That's not it. Handouts. Here we go. Did I already take them out? Yes, I did. Okay, so let me give you, I don't know, 3-4 minutes. Feel free to chat with a neighbor. And then we'll just go through these and make sure we can distinguish between deductive and inductive. Oh, number 7, I gave it to you. I use the examples in the notes. Oh, well. Okay, how'd we do? All right, ready? Let's see if we can breeze through these. So in the first section, you're just trying to distinguish, is this using inductive reasoning or deductive? So let's see, number one, using the Pythagorean theorem, Jackie determines the length of the hypotenuse of a right triangle. Carson,
Deductive.
that's deductive reasoning. Using definitions, facts, theorems, deductive. Sean has scored above a 90% on every geometry test. Good job, Sean. He reasons that he will score above a 90% on tomorrow's test. That's inductive. That's based on a past pattern. Okay, I hope he does, but it's not a guarantee, right? Unfortunately. Susie notices that the area of two triangles are congruent. She reasons that the triangles must be congruent. That is not necessarily true, is it? But anyway, is she using inductive or deductive? She's doing inductive. She's making an assumption based on previous things she has seen. That may hold true for squares, let's say, but it does not hold true for triangles. 4, by using the definition of equilateral triangle and perimeter, Jack reasons that the perimeter of any equilateral triangle is 3 times the length of a side. Carson?
Deductive.
Yeah. He's using the definition of equilateral triangle and perimeter, and it's true, right? The perimeter of an equilateral triangle is 3 times the length of a side. So yes, deductive. Not to say that you can't make a mistake if you use deductive reasoning. You can, you just made an error, right? So, but anyway. Okay, we're trying to find patterns. Number 5, 1, 1, 3, 7, 13. What do you think comes next? Anybody get this one? What comes after 13, you suppose? Aiden? And
30.
I agree. What was the pattern that you saw?
There's the addition of like 2 to every like 2. It grows by 2 every time.
Yeah. If you take a look at what you're adding, first I didn't add anything, then I added 2, then I added 4, then I added 6. So it's a logical conclusion that I would now add 8 and then add 10. Okay, again, this is inductive reasoning. I don't know 100% sure that I'm right, but this is a logical pattern that I could come up with. Okay, how about 6? 1, 1/3, 1/5, 1/7. Go ahead, what do you think comes next?
1, 9,
I agree with you. Oh. Thank you. So this time it looks like my numerator is just staying a consistent 1, but if you look at the denominator, I could write 1 as 1/1. So I went 1, 3, 5, 7, 9. So it looks like that denominator is just becoming the next odd number. And we already did 7 because that's the one that I just gave you in your notes. So there's just the prime numbers. Okay, now at the bottom, we're trying to see if I have a few statements. Let's see if I can make a conclusion. And maybe I can't every time. Let's see. All right, so Sally scored higher on the test than Ben. Okay, Sally scored higher than Ben. Rita scored higher than Sally. Can you make any conclusions based on these statements? Taylor, go ahead.
Rita scored higher than Ben.
Yes, you could conclude that Rita scored higher than Ben. Does that make sense? Okay, let's try number 9. The sum of 2 angles is greater than 90. One of the angles is obtuse. Can I make any conclusions here? Yeah, sum of 2 angles is greater than 90. I don't know anything about the second angle. Yeah.
Well, you can assume that the other 2 are acute. One equals obtuse.
But couldn't it also be obtuse?
Oh, it's not triangle.
Yeah, I just have 2 random angles. They could add up to anything. So if one is already obtuse, I don't know anything of, maybe it's acute, maybe it's a right angle, maybe it's a straight angle, I have no idea. So unfortunately, I can't make any assumptions with that. I don't get anywhere. And the last one, Sam is older than Alex. Jamie is younger than Sam. What can we say here, if anything? Cole?
Jamie is the youngest.
Jamie is younger than Sam. Sure.
Yeah.
Hold on. Jamie is younger than Sam.
Say Sam's the oldest.
It's saying that Alex and Jamie are both younger than Sam. So you can't say who's the youngest.
Oh, right. Oh, yeah. Thank you. But we do know, yeah, Sam is older than Alex. So Sam is older than Alex. Jamie is younger than Sam. So yeah, Jamie could be anywhere. Maybe they're the same. So I do know that Sam is the oldest, right? I could say that. Yeah, okay. All right, any questions here? All right, I am not giving you any additional homework than what is already due, because remember what you had from the stuff from last week that's due tomorrow. I do have a little half sheet review thingamajiggy. I'm gonna give it to you now. I'm not assigning it for homework. We will go over it tomorrow though, because it's so handy to know how to do these. Just saying. So let me give this to you. Try not to lose it.
So we're doing quiz number 3, 4, 3, 6.
Tomorrow's quiz is the multiple choice for the whole chapter. So this little half sheet that I'm giving you, if you don't get to look at it tonight, maybe after your multiple choice quiz tomorrow might be a good time to look at these. I would love to go over this. Sorry, I'll full punch through where your name goes. Great, there you are. Okay, let me shut off the video.
Like an actual.
I did.